Hey, welcome back. Let's take a look at page 3, which is problems 6 through 8. There's kind of a typo though. The first part of number 9 is at the bottom of the page, and it really should be one page back, but shouldn't be too big of a deal. We'll just go ahead and make that modification. But here we go. I want to write a polynomial, and I would like it to be in standard form with real coefficients according to these following pieces. Now, keep in mind, we should know if 1 minus I is a root, and so is 1 plus I. And notice it says -2 is a root of multiplicity 2. So what I know is that somehow I've got some polynomial that, now remember we had that special way of doing it, and I keep calling it a trick, but it's really more of a strategy or a memorized process, that if I add these two together, 1 plus 1 is 2, those cancel, so I get -2x, because remember, you always change the sign. And then if I square the coefficients, which are a 1 and a 1, I would get a 1 and a 1, so it's plus 2. So 1 squared plus 1 squared is 2. And then this is x minus 2. -2 is a root of multiplicity 2. So that is the fourth degree polynomial. The only problem is I need to find out what that leading coefficient would be that would actually make that work. And it does say that I want this thing to be in standard form. So we're going to go a little further, because if I took x plus 2 times x plus 2, which is what it tells me to do because of the root of multiplicity here, I'd get x squared plus 4x plus 4. And here's where we kind of went through a process in class of looking for things. So x to the fourth is here. I've got 4x cubed there and -2x cubed. So 4 minus 2 is 2x cubes. And then I go right here to look for the x squared. I had 4x squared minus 2x squared and 2x squared. So I've got 4x squared minus 8x squared is -4x squared plus 2 more x squareds make -2x squareds. Now I'm going to look for my x's, which are right here, -8x and +8x, which actually cancel out, which is nice. And so the only thing left is a plus 8. I guess I didn't need quite that much space. Now, that is pretty much the answer, but we had one little caveat that I said I wanted it to go through the coordinate 3, -10. So what I did is I plugged in 3 for all of the x values, and we could either plug it in right here or right here. It doesn't matter. It's actually right here is probably the easiest place. So according to the rule here, it says h of 3. I'm using f. I should have used h. H of 3, which would be 9 minus 6 plus 2. 3 plus 2 is 5 squared. So I've got h of 3 is a times, let's see, 5 times 5 squared, which is 125a, is somehow supposed to be, according to this, -10. So a has to be -10 over 125, also known as -2/25. So if we could put a right here as -2/25, we would be done. So this would be h of x. I'm going to change that to h like it's supposed to be in the problem, since it says that in the question. There we go. So h of x equals that. Now that's kind of not in standard form. I guess we could rewrite it as -2 over 25x to the fourth minus 4 over 25x cubed. 4 over 25x squared minus 16 over 25. But I actually kind of like that version a little bit better. But that would be a polynomial that has those given roots that also then would go through that one and only one place. Now, number 7 goes one step further and says, okay, if we have that one given value, can we go ahead and come up with the other one? Now, keep in mind, this is a fourth degree. If I gave you one of those zeros, because of the conjugate roots theorem, I actually gave you 2 of those zeros. Now, again, I totally know that some of you guys don't really like doing the synthetic division, but it's kind of my favorite. So if you would like to do long division using x squared, you add, you get 4. 2 squared is 4 plus 3 squared is 9. 4 and 9 make 13. If you wanted to do long division by that, that will give you an equivalent result. But I'm going to lean into the synthetic for a moment here. So we are going to do synthetic division using 2 minus 3i, and I just feel like I want people to get a feel for this. There we go. Let's make sure I get this thing to show up okay. So I said, let's take 2 minus 3i. And let's store that as a. So remember, we're going to drop the 1 first. And I'm going to multiply 2 minus 3i by 1. And keep in mind, I still have that right here. So I'm going to subtract 6 from that because I'm adding it to negative 6. That crazy number right there, I'm going to multiply it by a again, and that gives me negative 17 plus 6i. Keep in mind, I'm now going to add that to 18. Now, the nice thing is, as long as we have this stored in our calculator, it's going to do all the hard work. That's 20 plus 9i. Take away 14. 6 plus 9i. Times alpha a one more time. And what do you know? I got 39 plus no i's. And that gave me 0. Now, I knew that was going to happen because I told you it was a root. And so if we do the conjugate root, the nice thing is I will not need a calculator anymore because that would give me 2 plus 3i. Notice the negative 2, but the i's cancel. I get negative 4 minus 6i. Again, the i's cancel. This times this would be negative 6 minus 9i, and everything cancels. And so I'm left down with x squared minus 2x minus 3, which turns out to be a beautiful factor of x minus 3x minus 1. Oh, excuse me, x plus 1. Because I need them to multiply to negative 3, but add to negative 2. And so my roots, and there should be 4 of them, are 2 plus and minus 3i, positive 3, and negative 1. And we got all 4 roots that match up with this problem. Okay, number 8 is the last one, and we're just going to go ahead and talk about the nature of the problem and come up with a nice full look at the picture of this graph and come up with a little bit of info. So the first root that I see is I see 2 as a root of multiplicity 2. Now, so that means that at 2, we're either going to have a bounce going up, or possibly at 2, we're going to have a bounce going down. I don't know which one yet. We'll find that out. At 1/2, it's a root of multiplicity 1. So that place, it should come through like a line. And at negative 1, it's a multiplicity 3. So we should see a little S curve at that place. So coming down to here, I'm going to put a root at negative 1. I'm going to put a root at 1/2. And I'm going to put another root out here at 2. Now, I also know that based on the powers of everything, when I take a look at the limit as you go to infinity, remember in behavior is talking about limits as you go to infinity, performed on f of x. Remember, we have to say what we're doing. But I have a 3, 4, 5, 6th degree polynomial. That's 3 from here. 1 from here, that's 4, 5, 6th degree polynomial. And if I multiplied it out, the leading coefficient would be negative. So that means both of these things are going down to negative infinity. So I know that somehow the graph has to be down. So I know that the graph at negative 1 is some kind of an S curve, and it's going to go down. I know at 1/2, it's some kind of a line. And at 2, it's a parabola, and it has to go down in order to match up with the end behavior. Now, the only thing left that I would like to do is I would like to come up with some little points. So like for me, if I tried f of 0 and I went to the original problem, I got 2. And I literally just plugged in 0 plus 1 is 1, cubed is 1. 2 times 0 minus 1. I literally just plugged in 0 and saw what I got, and I got 2. And then I also tried f of 1, and when I plugged in 1, I got negative 4. Turns out these aren't too bad in numbers. So I've got 1 at negative 4, and I've got 0 at 2. This thing didn't actually have a lot of room to move, did it? So it's going to come up something like this, and then it's going to come down. turn the corner and go back up and then go back down. And I did this on purpose because notice that doesn't look like the peak is dead on at that 0, nor is the minimum at dead on at that value. I don't know exactly where it is. It might be a little bit to the left. In fact, I'm suspicious that this one might be a little bit to the left and then coming back down, but I just didn't want to imply that I felt like this was the maximum or that that was the minimum. So that's the end of that problem, and we'll pick up the last ones on the next video. Bye-bye.